This is our flip class video for section 9.2 in Honors Algebra 1. So in section 9.1 we talked about adding polynomials, and so today we are going to talk about multiplying polynomials. Obviously there's a difference, and so there will be a little bit different procedure, process to follow here, a little bit different reasoning. But I think we'll be able to get you there by the end of the video. So we're going to start off with an example from geometry. Number one says, write a polynomial that represents the shaded area. Obviously, the shaded area is illustrated there, pretty easy to see. As far as a general strategy goes, I think probably what we should do here is take the area of the large rectangle minus the area of the small rectangle. So that'll give us just what's left over, the shaded area. So, as mentioned, we have two rectangles. How do you find the area of any rectangle? Of course, it's base times height. So the large rectangle's area is going to be x plus 1 times x plus 1. We're going to subtract from that the area of the smaller rectangle. So the base is x minus 7 and the height is 5. Okay, so we were supposed to write a polynomial that represents the shaded area. So in order to do that, we are going to have to go ahead and multiply the two factors that we have here in each term. So let's do the second one first. The second one actually should be familiar to you. It's something you've done in the past. Do you recognize the property that's being illustrated? Sure, yeah, hopefully you said distributive property. So 5 gets distributed in to the x minus 7. I am going to leave the parentheses for now because we are subtracting. If you remember from 9.1, that makes a difference. So it's going to be 5x minus 35. So that's actually nothing new. The first term is, whenever you have a product of two different factors like this, we need to take a quick look at it and decide what we have. First of all, notice that they're the same factor, right? They're both x plus 1s. And please notice that both of those are what we call binomials. If you remember from the 9.1 video, a binomial is an algebraic expression with two terms. So whenever we have a binomial times a binomial, we're going to use a special pattern. It's called FOIL, F-O-I-L. I'll write this out here for you. And FOIL is what we call an acronym, which means each letter stands for a different word. So the F stands for firsts. What that means is we need to multiply the firsts together. So our firsts are x times x. So x times x is x squared. Remember, we're multiplying here. So x plus x is 2x, but x times x is x squared. That's one of those things that folks will get confused on from time to time. So try to keep them straight. Okay, O stands for outers. So my outers are x times 1. So that would just be plus 1x, or if you just wanted to write x, that's fine as well. The letter I stands for inners. So my inners are the 1 times the x. That's another plus x. And then the L stands for lasts. So that would be 1 times 1. So plus 1. Okay, you're going to find that a really common pattern happens when we FOIL. You're going to find that the two middle terms usually are like terms. They can be added together. So in this case they are. So it's going to be x squared plus 2x plus 1. And if it's okay with you, I'm going to go ahead and use the process we talked about last time with subtraction. I'm going to drop the parentheses and then distribute the minus sign. So it's going to be minus 5x plus 35. What's left for me to do here is just add my like terms. So my first term is x squared, and there is nothing like it. So I'm just going to leave that alone. Put that in my answer. The next term is positive 2x, and that does have a like term. It's the minus 5x. So a 2x plus a negative 5x is minus 3x. And then finally, I've got a constant, and I've got another constant. So 1 plus 35 is 36. Okay, so that polynomial right there, what that does is that represents the area of the shaded region. The reason I know that is I took the area of the larger rectangle minus the area of the smaller rectangle. What's left over is the shaded region. We could plug anything in for x, given an x value, and we could find the actual area of that shaded region. Okay, so we've got a couple of examples coming up here that are things that you might be able to do now. So if you take a look at numbers 2 and 3, if you want to pause the video and try these on your own, it'd be a good idea. Let's see if you can handle these. I'll continue. You can check your answer. Okay, so number 2 is, if you notice, it's a binomial times a binomial. So whenever you see a binomial times a binomial, we're going to FOIL. Okay, so FOIL, the F stands for firsts. So that would be 3x times 2x, and that's 6x squared. So 3 times 2 is 6, x times x is x squared. O comes next, that stands for outers. 3x times 9, 27x. And then I have I, which stands for inners. So my inners are right here. Negative 7 times 2x is minus 14x. And then finally I've got my L, which stands for lasts. So that would be negative 7 times 9, which is negative 63. All right, as is typical, my two middle terms can be combined. So 6x squared and positive 27 and a negative 14 makes 13. So 13x. Notice I'm being consistent. I am being consistent with the rules that we talked about in 9.1. Whenever you add terms, you combine their coefficients, but you leave the exponents in the variable alone. Okay, number 3. Notice that number 3 is not a binomial times a binomial. It is a monomial times a binomial, but we better know this is the distributive property. So I'm simply going to distribute that x squared across. So let's start off with the first one. X squared times x cubed. Notice that the coefficients on both are 1s. So it's going to be 1. I'm not going to write that though. But then whenever you multiply bases, what do you do with your exponents? You add them. So this is using the exponent rules back from chapter 8. And then as we distribute across, we're going to get x squared times negative 7x. So it's going to be minus 7x to the third. Because 2 plus 1, as I add my exponents, 2 plus 1 is 3. Of course, just a note here, these two terms are obviously not like terms, and so we will not attempt to combine them. All right, so number 4, I think, oops, and there it goes. Going a little too far there. Number 4 is coming back. There it is at the top. This might be another one you can handle on your own. So if you think you can, go ahead and pause the video and try it by yourself. Otherwise, I'm going to keep moving. Okay, please notice what we have. Our setup is a binomial, two terms, times another binomial. You can see the two terms right there. And so what we're going to do, sorry about that, what we're going to do is FOIL. Whenever you have a binomial times a binomial, our strategy should be FOIL. If you look at your book, there are definitely other strategies, but I found FOIL seems to work the best. If you want to talk about other ones, be happy to. Okay, so F stands for firsts. So as I multiply my firsts, I'm going to multiply my coefficients. So 5 times 3 is 15. And then I'm going to add my exponents. So 2 plus 4 is 6. Let me give myself a little more room here. So 15x to the 6th. All right, as I go through FOIL, the next letter is O. That stands for outers. So once again, I'm going to multiply my coefficients. 5 times 7 is 35. And then there isn't a variable with a 7, so it's going to be 35x squared. The next letter is I, which stands for inners. I'm going to multiply my inners together. Once again, multiply the coefficients. -1 times 3 is -3. And then x to the 4th is the only variable, so that remains. All right, the last one is L for lasts. So -1 times 7 is -7. So like I said earlier, typically you will have middle terms that can combine. But notice in this case, you don't. It doesn't work out that way. As I look at my terms, I've got x to the 6th, x to the 2, x to the 4. So none of those are like terms, and so there's nothing that can be combined. One thing I will do to clean it up a little bit is I'm going to write my polynomial in descending degree. So it'll be 15x to the 6th minus 3x to the 4th plus 35x squared minus 7. So I'm basically just swapping the two middle terms, and I can do that as long as I keep the sign in front of the term with the term. So it would be our final answer. All right, number 5 is a little bit newer. If you notice, the reason why I say that is because we don't have a binomial times a binomial, or we don't have the distributive property. What we have there is a binomial times a trinomial, right? The second factor has 3 terms in it. So I'm just going to use a slightly different strategy here. I'm sure maybe by this time you've noticed that FOIL is simply just a kind of an organized way of multiplying each of the terms in one times each of the terms in the other. It's nothing magical about it. It's just a kind of an organized system for approaching those types of problems. So what we're going to do here, this doesn't have a cutesy name. What I'm going to do is I'm going to distribute or multiply the 2x times everything in the trinomial, and then I'm going to multiply the 5 times everything in the trinomial as well. That's going to be my general strategy. So I'll start back over here, and we'll get some details right. So 2x times 3x squared. As always, multiply coefficients, add exponents. So 2 times 3 is 6, and then x times x squared is x cubed. All right, 2x times -8x. Multiply coefficients, add exponents. So 2 times -8, -16. X times x is x squared. 2x times 5. Again, multiply coefficients. So 2 times 5 is 10. Add the exponents, but the truth is there's only just one x there. So there's nothing to combine with that. All right, if you want, pause the video, see if you can do the other half of this, and then combine your like terms. We'll check at the end. All right, continuing on. 5 times 3x squared. Once again, multiply coefficients, add exponents. So 5 times 3 is 15. And the only variable is x squared, so it's going to be 15x squared. Continuing on. 5 times -8x, we're going to multiply those coefficients, -40x. And then finally, 5 times 5, of course, is 25. No variables to deal with there. So our final step is going to be to add our like terms. So first is 6x cubed, and there's nothing like it. So that's just going to be dropped down to our answer line. The next is -16x squared. What's like that is positive 15x squared. So with these, what we're going to do is we're going to add our coefficients, and we'll leave the variable exponents the same. So -16 plus 15 is -1x squared. You don't have to write that 1 if you don't want to. Okay, 10x is my next term, and -40x is like it. So I add those coefficients up. 10 and -40 is -30. I leave the variable the same, -30x. And then my final term, of course, is the constant, the 25, so that just gets tagged on to the end of the answer. Notice we are in descending order of degree. The degree, of course, is 3. This does have 4 terms, so we would probably just call it a polynomial. And one term we haven't talked a whole lot about yet, I think it might have been in your homework, possibly, is this number right here. Whenever you're in descending order of degree, we have what we call the leading coefficient. This gets pretty important later on. So the leading coefficient in this case is a 6. The fact that that's positive, the fact that that's a 6, is pretty important. Okay, one last chance for you to practice foiling, just in a practice setting. Take a look at number 6. If you want, pause the video and try this on your own, and I'll catch up later. Okay, so the reason why this is a FOIL is because you have a binomial times a binomial. So my first, in the word FOIL, the first letter is F, which stands for firsts. So we're going to go x times 3x. So again, when you're multiplying, you multiply your coefficients and add your exponents. So 1 times 3 is 3, and then x times x is x squared. Outers. X times 4y is simply 4xy plus 4xy. No combining can be done there. All right, and then we got negative y times 3x for my inners. So that would just be minus 3xy. And finally, I get to my lasts. Negative y times 4y. Negative times a positive is a negative. 4 times 1 is 4. Y times y is y squared. Check your middle terms. Can those be combined? Are those like terms? Yes, they are. So we'll combine them by addition. A positive 4 and a negative 3 just makes a 1. And then we leave the variables and the exponents alone. And there's our final. Okay, I think this is our final example. Yes, it is. Okay, so pretty classic problem involving a swimming pool and a sidewalk. So it says a rectangular swimming pool is to be bordered on 2 sides by a sidewalk as shown. Part A says write a polynomial for the combined area of the pool and the sidewalk. Well, first of all, notice your shapes. We have a rectangle. We have a kind of a smaller rectangle and then a bigger rectangle. So the combined area, well, let's see here. The area of any rectangle is base times height. So let's figure out the base length for this, this rectangle. So the base would be from the left edge all the way over to the right edge. Let's see here. We're given a couple of measurements here. We know that the sidewalk is x feet wide. We know that the pool is 90 feet wide. So looking at the picture, to go from here to here is 90 feet. And then to go from here to here would be x more feet. So then how do I get the full base length? Is it going to be 90 times x or 90 plus x? Well, the truth is it's going to be 90 plus x. If you think about it, if the sidewalk, let's use a number just to think this through. If the sidewalk was 5 feet wide, for example, wouldn't the full width be 90 and then 5 more, 90 plus 5? It wouldn't be 90 times 5. That'd be 450. That doesn't make any sense. So just like you would go 90 plus 5, we're going to go 90 plus x. So my base is 90 plus x. Okay, now we're going to get the height in a similar way. The height is from here all the way down to here. And to do that, we're going to have to go 50 feet and then x more. So that's going to be 50 plus x. Similar, like I said, to the other one. So that's not a polynomial yet. We're going to need to multiply this out. What process would you use to multiply this out? I hope you just said FOIL. The reason why we'd use FOIL here is because we have a binomial times a binomial. So here we go. F stands for firsts. 90 times 50. I believe that is 4,500. My outers, 90 times x. Of course, that's 90x. My inners would be 50x. My lasts would be x times x, which is x squared. So a little bit of cleanup work to be done here. Notice the middle terms are like, and so 90x and 50x can be combined. And I'm going to write my answer in descending order of degree. So that means my x squared needs to come first. And then 90x and 50x is 140x. And then I'll put the plus 4,500 on the very end. So that's a polynomial that represents the combined area of the pool and the sidewalk. Okay, last one. If the width of the sidewalk is to be 12 feet, use the polynomial from part A to determine the combined area of the pool and the sidewalk. Well, notice, if you remember, x was set up to be the width of the sidewalk. So they're basically telling us that x is 12. So I'm going to say something like a of 12, we use function notation, is equal to 12 squared plus 140 times 12 plus 4,500. I'm simply plugging in a 12 for the x, and since the x stands for the width of the sidewalk, I think we're good. Okay, so multiplying and adding everything together here, I'm coming up with 6,324. So a of 12 equals 6,324, and since it's area, it would be square feet. All right, so I know this is a longer video. I hope that you got everything you needed out of it. If not, obviously go back and rewatch sections of it that you need to. Good luck. I hope that it went well for you. I'll see you at next class.